All right, in this example, we have a bacteria colony that has an initial population of 14 million bacteria. And suppose that t hours later, the population is growing at a rate of f of t equals 4 to the t, million bacteria per hour. Okay, so what we have is a formula for the rate, right? This is the formula for the rate at which the bacteria are multiplying, right? The population is growing. All right. So the first part just asks us to write a definite integral that represents the net change in the bacteria population from time t equals 2 to time t equals, time t equals 0 to time t equals 2. So basically over the first 2 hours. All right. So our t values we're going to integrate from 0 to 2. And the value of the rate is 4 to the t, and then the width is dt. So this is going to represent this is the integral that represents that net change in the bacteria population, right? We're just taking the rate times the time to get the total change in bacteria, but then we're slicing and adding that, slicing that into an infinite number of pieces and adding all those little rectangles up, right? So this gives us the net change in the bacteria population. Now, the next question is asking us to estimate this integral using left and right hand sums, and n equals 4. Okay, so n equals 4, we're going to take the interval from 0 to 2 and break it into 4 equal parts. Okay, so now, if you remember in example 1, right, we actually put that in a table. And so let's do that. Let's go ahead and just do it in a table. I'm going to have t, and I have 4 to the t is my function. This is my f of t. All right, I'm going to just make a little table here. I could make it horizontally or vertically. I'll just make it horizontal. And so I want to integrate from 0 to 2 with four equal subintervals. Okay, so I'm going to have to, every subinterval is going to have to be a half, right? So I'm going to have 0, I'm going to have 0.5, I'm going to have 1, I'm going to have 1.5, and then I'm going to have 2. Okay, those are my little those are my subintervals. So I get 4 subintervals. Notice I have 5 values, right? I need 5 values to have 4 subintervals. All right, now I'm just going to I can put this into my calculator, or I can actually, a lot of these I can just figure out on my own because I, without a calculator. But 4 to the 0, okay, 4 to the 0 is 1. 4 to the 1/2, right? That's the square root of 4, which is 2. 4 to the 1 is 4. 4 to the 1.5, that's 3/2. So that's the square root cubed, which gives me 8. And then 4 squared is 16. Okay, so I could do that actually without a calculator. But you can use your calculator, that's fine. All right, and then I have to find the left and right hand sums. So I'm going to write L4, because I have 4 subintervals. And the interval width is a half, right? So that's my delta t, and then I'm just going to add up the first 4 values of f of t. So 1 plus 2 plus 4 plus 8. All right, when I add that up, I got 7.5. Okay, 7.5. So add that up. Looks like it's 20. Yeah, it's 15 divided by 2, so 7.5. Okay, so then let's do the right hand sum, R4. And again, the interval width is a half, but now I'm going to add up the values of f of t on the right hand side of each subinterval, right? So 2 plus 4 plus 8 plus 16. I added that up and multiplied by a half, and I got 15. Okay. So now it says average of left and right hand sums. So let's go ahead and average those two. That gives us an even better estimate. Average. The average is going to be 7.5 plus 15 all over 2. All right, so I'll put that on my calculator. I got 11.25. Okay, so what is that telling us? This is just an estimate, but it's telling us that this is the net change in the population, right? This is the units would be in because my F of t was in million bacteria, right? It was in millions of bacteria, right? Millions of bacteria. Initially had yeah, so it's in millions of bacteria per hour, right? Times hours. So this is in millions of bacteria, million bacteria. Okay. Now, what is that? That's the net change. That's the net change in the population. Now, we didn't start with zero population. We started with 14 million bacteria. So, using this estimate, what is the total population of the bacteria after 2 hours? So, it started out, so let me write down total population, okay. We started out with 14 million bacteria, and over the course of this 2-hour period, we added about 11.25 million bacteria, right? So that gives us a total of what, 25.25, and again, the units are million bacteria. Okay, so so the key thing is that when we integrate this function, what we get is the net change. Okay, and we estimated the integral with left and right hand sums. All right, I'll see you in the next video for the next example.